Previously, we've looked at a lot of examples of solving equations where there's really only one step to take to get the variable all by itself. So we're going to look now at situations where we have to take multiple steps in order to isolate our variable. And so when there's multiple steps, the question of course becomes, in what order do I apply the steps? Does it matter what order I apply the steps in? And if so, what is that order? And so before we get into either of these examples, let me remind you of problems that we're already familiar with where the order matters. So as an example, let's take something like this. We have 5 times 4 minus 2 squared plus 1. So this is a problem that has multiple operations, and so we know that when we have a problem like this, we're supposed to follow PEMDAS, right? Which means parentheses come first, exponents come second, then multiplication and division, and then addition and subtraction. So I would first subtract 4 and 2 because 4 minus 2 is in parentheses. That'd be my first step. Then I would square my 2 because exponents come after parentheses. Then I would multiply 5 and 4 because that comes before addition. And then finally we would add those and get 21. So we apply this order of operations whenever we want to simplify an expression like this. Well, one way to think of solving an equation is that you are undoing the things that are being done to x. Okay? So you're undoing it. So if I was to work this process backwards, I would first undo the fact that I added, right? Then I would undo the fact that I multiplied. Then I would undo the fact that I applied an exponent. Then I would undo the fact that I simplified in parentheses. So notice if we undid everything, we'd have to go backwards. And so that's essentially what we do when we solve an equation, is we apply the order of operations in reverse. And so I always write it out like this, SADMIP, right? So I just turn these letters around and go backwards like this. So when I look at 3x plus 4 equals 13, I can see x is being multiplied by 3 and then 4 is being added. And so since I'm going the reverse order of operations, I'm going to take care of the addition of 4 first. And so to get rid of that 4, I know I'm going to subtract 4 from both sides. So that leaves me with only 3x on the left side and 9 on the right side. And then of course we need to get rid of that 3. We're multiplying by 3, so I can get rid of it quite easily by dividing both sides by 3. So I end up with x equals 3. Okay. Moving over to this side, I have a 3/5 times my a, and then I have 6 minus that 3/5 a. All right, so what do I do first? Well, I deal with this 6 first, right? Because even though it's 6 minus 3/5 a, I could think of it as negative 3/5 plus 6. And so this is definitely my first order of business. So I subtract 6 from both sides as a first step. That gives me 9 equals negative 3/5 a. And then I know I can get rid of negative 3/5 a by multiplying both sides by its reciprocal, or flip. So the reciprocal of negative 3/5 is negative 5/3. And since I'm multiplying 9 by a fraction, I'll make that 9 over 1. Okay. And I'll do the same thing over here. Negative 5/3 times negative 3/5 a. All right. So we can see all the cancellation happening here. And everything's canceling on the right side, which is of course what we need. And so what we end up with is that a is equal to negative 15. So negative 15 equals a. And a quick note here, it really doesn't matter whether the variable's on the left or right at the very end. That doesn't matter at all. So you don't need to feel the need to flip it around just to box up your answer. And then one other thing I want to point out, and it's something I did a good job of in the first example and not quite as good of a job in the second example, and that is, now that we start having multiple steps to take in our equation solving, what we want to do is do our best to line up the equal signs in each of our equivalent equations. That'll just help us keep things organized. So if you can make those equal signs go straight down the page, that's going to really help you keep things organized. It'll help you remember to rewrite all parts of the equation that you haven't changed. I didn't do a fantastic job here. I was kind of not doing a great job, but it's kind of close, I guess. Just kind of a little wiggle there in that second step. So if you can make this look more like this, then that's definitely a good thing. So that's something that I think will help you keep things organized and make fewer mistakes.